Number 10. Determine the electronegativity difference, the probable bond type, and the more electronegative atom with respect to bonds formed between the following pairs of atoms. Now notice here in the instructions that say the probable bond type. As we saw in number 9, in fact, sometimes when we look at things like quick tips, they don't fully describe the nature of the bond for a few kind of wacky reasons that do make sense, but they're more exceptions to rules rather than rules that we need to memorize. So right now we're okay with just probable. Okay, probable, based on electronegativity differences and the ranges that we have associated with those electronegativity differences. More than likely, in general, what is that bond type going to be? Okay, so it's a nice simple question. We're not going to be focusing on exceptions here. So A, hydrogen and iodine electronegativity difference calculated comes out to 0.4. That puts it squarely in the polar covalent category. Anything from 0.4 all the way up to 1.7 is going to be polar covalent. The more electronegative element here is iodine. B, sulfur and oxygen. Electronegativity difference comes in at 1.0. That is nice and neatly in the polar covalent category. The more electronegative element between the two is oxygen. In C, we have potassium and bromine with a fairly large electronegativity difference coming in at 2.0. That makes it an ionic bond. The more electronegative element is bromine. D, silicon and chlorine, electronegativity difference coming in at 1.2. That makes it polar covalent. The more electronegative atom is chlorine. E, hydrogen and fluorine. Okay, we saw this pair a little bit earlier. Electronegativity difference is 1.9. So that makes the bond type ionic. The more electronegative atom is fluorine. In fact, it's the most electronegative element on the periodic table. F, selenium and sulfur. Electronegativity difference is 0.1. So that's going to put it in the non-polar covalent category. Whereas even though it's a very small difference, the more electronegative element is sulfur. And so one thing I want to point out here is that I'm asking you to identify the more electronegative element. Right? That's for a very specific reason. Now, it's a very simple question in and of itself. Which one is more electronegative? Which one has the larger number associated with it in the electronegativity periodic table? But more than that, we can use that information to help us figure out which element is going to have a partial negative charge, which element is going to have a partial negative charge, whichever is not the one I just said. I already forgot. But when we're asked around which element, around which atom are the electrons more likely to spend more time, well, it's the more electronegative element. And so if you can identify the more electronegative element, you can answer questions like that. Around which nucleus will these bonding pairs spend more time? Whichever is the more electronegative.